All right, let's finish off this problem. In previous videos, we have determined that AE has some value. We didn't calculate it out, but we know what that is, and TAD has a value. So those are known values, and I've labeled that here as known. We've also discovered that this red truss that we had, or that red member in the truss, was a zero force member, at least in this situation it is. Same thing over here. So I put those in red just so that we're going to ignore them, but physically they exist, but as far as the problem goes, they don't. All right, and so what we want to do now is we want to kind of finish off looking at the various joints, and we're going to start at D. We're going to look at joint letter D here, and then we want to look at the forces that are acting at that point. All right, so here's a free body diagram or a force diagram specifically for joint D. And I can do the sum of the forces in the X, and I've only got two, and so that's TAD cosine theta, that's to the left. Remember, TAD is known, so TAD cosine theta, and that's going to be negative because it's pointing left. And then TDF cosine theta, and that's to the right, and so that's going to equal 0. And so what we've discovered then is that TAD, because I can bring this to the other side and the cosine thetas go away, TAD is equal to TDF. Right, so TAD equals TDF. And I got TAD when I did joint A. All right, and then some of the forces in the Y, I'm going to have TDF sine theta. That's the upward component, the Y component of TDF. And then I have TAD sine theta, but that points down. And so notice, since I already know that TAD and TDF are the same, these two terms will cancel each other out. And I'm going to be left with, in a downward direction of 400 pounds, and in a downward direction of TDE, so minus TDE. And that's equal to 0. And so I've discovered then that TDE is equal to negative 400 pounds, which means TDE is in compression, which makes sense because there's 400 pounds pushing on it. So it makes sense that if I'm pushing down on TDE, it's going to be in compression. All right, and so TDE is now known, right? So I'm going to label that as known. And TDF is also known. All right, so that's truss D. All right, so from there, let's move up to F, and let's see what we come up with when we look at F, and then we'll also take a look at H here. All right, so let me bring these down. Remember now that TDE and TDF are known. All right, so here are those two trusses. This is known. Okay, so that's a known value. All right, so when I look at F, a couple of things to keep an eye on. TFH and TFD or TDF, they point at an angle theta below the horizontal or above the horizontal. And then TFG, I've labeled this angle alpha. TFG is below the horizontal. And alpha, if I extend this horizontal over, this is going to be 4 feet. I know that because this is 6 feet, 6 feet, 6 feet. So this will be 1/3 of the way up, and it's 6 feet from the bottom to the top. Right, so I've erased that here, but this is 6 feet. And so 4 feet and then 6 feet across here. So the arctangent of 4 feet over 6 feet will be alpha. And so alpha is the arctangent of 2/3. All right, so I need those angles. I don't care what they are, I know that I can calculate them out. All right, so let's take a look at our equations then in here. So far, we've found everything. All the trusses, all the members of this truss so far have been determined, but let's keep going. All the members that we've encountered so far. All right, so some of the forces in the X direction here. So I've got TFH cosine theta minus TDF cosine theta. Right, this is pointing up and to the right, this is pointing down and to the left, and then these both pointing down, but one to the right and one to the left. And so that's going to be plus TFG cosine alpha. Again, I know what alpha is. Let's see, that's to the right. And then minus TEF cosine alpha. That's going to equal 0, right? And so I know TDF, but I don't know FH, FG, or EF. And so I have 3 unknowns up in there. Right, so I'm just going to label this as 1, this is 2, this is 3. Remember, TDF is known from previously. And some of the forces in the Y, I'm going to have TFH sine theta pointing up, TDF sine theta pointing down, so that's negative because it's pointing down. And then both of those are pointing down, so minus TEF sine alpha minus TFG sine alpha is equal to 0. All right, so the same 3 unknowns that I had in line number 1. So I have 3 unknowns and 2 equations. All right, so I can't completely solve those out. All right, so then we're going to move over to the pinnacle of the truss, and that was point H. And the sum of the forces in the x direction, I have TFH and THI. So the TFH cosine theta, that's pointing left, plus THI cosine theta, that's pointing right, that's equal to 0. And so TFH equals THI. That really hasn't helped me any because now I've added another unknown. So this is my, well, let's label it up here. This is a 4th unknown. Although, this is really not surprising because if we go back to the original drawing, TFH is pointing down to the left, THI is pointing down to the right. And we talked about this earlier, as long as I've got symmetry going on, which I do in this example, I know that this truss and that truss are going to, this member and that member of this truss will have the same force. So this really hasn't given me any kind of new information. That's really not very interesting in there. But if I do the sum of the forces in the Y, I've got 1,000 pounds down, and then I have TGH down, and then I have TFH and THI, but TFH is here, THI is there. Again, symmetry says they're the same. So again, in this case, they're symmetric and they're the same. And so I'm going to just say, make my life simple, I'm going to say minus 2 TFH, right? Minus 2 TFH sine theta is equal to 0. And so TFH was here, TGH, I'm going to not worry about this being my 4th unknown because it's the same as TFH and I'm aware of that, right? But TGH I don't know, and so this is a 4th unknown. So I have 1, 2, 3 equations. This equation really isn't of much value right here. So I'm just going to kind of cross that out. So I have 3 equations, but 4 unknowns. So I need to keep going. All right, so where am I going to go? I'm going to move down here to the bottom and over here to the bottom over here, right? So I've got those 2 locations. Let's start at E. If I look at E, which is right here, again, I know TAE. So the sum of the forces in the Y, I have TDE. But if we go over here, TDE is now a known. Right, so I discovered that here earlier yet. So that's actually a known. And then I have plus TEF. Take a look at EF. EF is here, that angle in here. This is also alpha, because this is 4 feet and this is 6 feet. So that's the same angle alpha. All right, so there's an alpha in here. So TEF sine alpha. And that's it in the Y direction, so that's equal to 0. And so I know TDE. TEF's the only thing I know what alpha is, right? So this was in compression, remember. So TEF is now known. And that was one of my, this was unknown number 3. If we go back to this board right here, right, TEF was unknown number 3. And so there's 4 equations, right? Excuse me, go back to this board. 1, 2, 3. And then this is equation number 4. So I've solved for those 4 unknowns, right? I've solved for those 4 unknowns. But I don't know TEG, and so I need to do the sum of the forces in the x direction, and I'm going to get TEF cosine alpha plus TEG. Make sure, yeah, TEG was not one of the unknowns up there. Minus TAE, which is a known, that equals 0. And so I've got all of that. So this is known, this is known. And so TEG is the only unknown in this equation, so I can solve for TEG. And I think I might not need this. I think that's it. So TEG I now know. TFG, that was one of the unknowns in the board that's up above. TGH, that was one of the unknowns in the board up above. And then symmetry is going to give me, because remember G is the bottom of the center span, these are going to be the same as these two by symmetry. So we have solved for all of the unknowns, all of the members have now had a solution, right? So I've got everything. So that's all of the members solved on the left-hand side by symmetry. That gives me everything on the right-hand side. All right. Whew. All right. That problem's done. If you have any questions, please leave them in the comments below. Thank you.